Alrighty, ladies and gentlemen. So it's time to do predicting products. Woohoo! Yeah, I like this. Alright, so this is Unit 4, pages 5 and 6 we're going to cover today on your notes. Pardon me, I'm eating some food while we do this. Don't yell at me. So, balancing equation is pretty easy. Predicting products gets a little bit more complex. So we'll start off with, here's an example for us for synthesis. Remember, synthesis is just two elements. Here you go, put them together. That's it. There's the two elements, we put them together. So we look right here, beryllium nitrate. So beryllium, well, if I look at my handy dandy periodic table, look at that, it just kind of flies in here. All cool like that stuff. Beryllium's right here, so I'm just going to write it down. BE. Okay, just like that. Now, nitrate's a little bit more complex. Because nitrate, if it ends in 8, it's going to be one of these common polyatomic ions. So we're looking for nitrate, nitrate, nitrate. There it is. NO3 with a -1 charge. Remember, we always write these in parentheses. And I'm just going to write the -1 charge because that's what it says on the table. Now, I prefer to do my formula first, or my equation first, and then write my words in. So I'm going to put them together. Well, beryllium has a +2 charge because it's in group 2. So when I crisscross the charges, I'll just work this out step by step. +2, -1. Now the 2 is going to go down here, the 1's going to go there. BE, parentheses, NO3. And that 2, remember, is going to be on the outside of the parentheses. So this is what my answer should be right here. BE, NO3, 2. Now, if I name that, well, BE, we already know it's beryllium. And nitrate, because beryllium is a representative element, it's not a transition element, we don't have to worry about any Roman numerals, so we'll just call it as it is. Beryllium nitrate. You can't change the ending on nitrate because it is already its own polyatomic ion. So you're done. That was easy, we just copied the answer. There you go. Alright, let's do a little decomp. So remember, decomp, we start with a compound and then the elements, or the parts, the cation and anion parts. We'll do this easy one down here. So, lithium sulfide. Well, lithium, pull out my handy dandy periodic table. There he is, right there. So lithium is Li. And sulfide, well, because it's IDE, we know it's on the periodic table. There he is, sulfide is sulfur, so his name is S. Okay? Now, we need to write the formula. So, lithium has a +1 charge because it's in group 1. Sulfur has a -2 charge because it's in group 6. Group 6A, or 16, crisscross applesauce, Li2S. Now name it. Well, name the metal. The metal is lithium. And there's a symbol. Name the nonmetal. Well, when he's not bonded, he's no longer sulfide, he's now sulfur. And he's just an S because he's not a diatomic. Remember that these are what you call the diatoms. If it's a diatom, we need to denote it as a diatom. Sulfur's not, so it'll just be Li plus S. Look at that. Hoop, there it is. What to do? The last one, let's do a combustion reaction. Oh, I've done second, I've done third, we'll do the first. So remember, combustion reactions always end in carbon dioxide and water. And so carbon dioxide and water. Now, this side, oxygen's a little bit complex. Remember, oxygen is one of those ones at the top. It's a diatom, so oxygen always has to be O2 in elemental form. So you need to make sure you have it in O2 in elemental form, just like this. Okay? Alright, so that's page 5. Let's go to page 6. Page 6 now is kind of mixed. So they might be decomposition, they might be synthesis, they might be a combustion. You just never know. Well, we'll do the top one. Why not? Rubidium Phosphide. So rubidium is Rb. How do I know? Well, my handy dandy periodic table showed it to me. So go down here, looking, because I know the first one's always a metal. There he is, Rb. Phosphide. The I tells you it's going to be a single element. Well, phos is phosphorus. Once again, look at my handy dandy periodic table. We know the second element's always an anion or a nonmetal. There he is. Now, I have to know the charges too. Well, rubidium's in group 1, so that's a +1. And phosphorus is in group 15 or 5A. And so if you track that from 8, it gives you a -3. Now, this is going to probably be what? A decomposition reaction, Mr. Rouse. You're right, it is a decomposition reaction, youngin'. How do you know? Because you have 2 blanks over here. You take one compound into 2 separate elements. That is a decomposition reaction. So, to do that, you just simply write the metal and the nonmetal. But remember, or the anion, phosphide becomes phosphorus. Rb, P. Well, we forgot to finish doing this over here. So the compound's actually Rb3P. This is really my compound right there. Okay. Phosphorus isn't a diatom, so you don't have to worry about it. So we're good to go. Let's jump on down. Let's do number 13. Don't want to do any of these that are too hard. So oxygen and aluminum. Well, I have a metal and a nonmetal, and I have one blank. So if I take 2 elements and put them together, that's what? Why, yes, it is synthesis. Awesome sauce. So, write the symbols. Well, oxygen, remember, oxygen is O, but it's a diatomic, so it's not just going to be O, it's going to be O2. And aluminum, over here on the periodic table, there he is right there. Oh, let me take the glare off. So he's Al. Now, if I write them over here, now remember, here's the thing. The metal, the cation, always goes first. The metal, which is the cation, always goes first. Well, how do I know aluminum's +3? Because where it's out of the periodic table. There he is. Aluminum's here. He's in group 3A or group 13. +3. Oxygen's over here in group 16 or 6A. So he's -2. Crisscross applesauce. There's my formula. Now, name it. Well, Al, aluminum. O, because it's single bonded O, it's just oxide. Aluminum oxide. Alright, last one for this homework. For me, you have to keep going. So we have here hexane, CH, and oxygen. Remember, oxygen is what? O2. Oh, it's CHO. It's CHO, boys and girls. So if it's CHO, we know it's a combustion reaction. A combustion reaction always ends in carbon dioxide and water. Water. Very important. Look, that one was the easiest one of them all. Well, good job. Keep working and get her done.